Okay, let's have some fun rationalizing denominators. So let's look at this expression. I have a square root of 3 over 20. So the first thing I would say, oh, my radicand is a fraction. Let's see if I can reduce it. 3 and 20 cannot reduce. They do not have a factor in common other than 1. So we're stuck with that fraction. So then I could say, well, I could rewrite this expression because this square root belongs both to the numerator, the 3, and the denominator, the 20. And I would have square root of 3 divided by square root of 20. Now again, there's division here. They're both square roots. But the question is, can you divide 3 by 20? No, you cannot. Okay? Do any of these radicals reduce, simplify? 3 is a prime number, and it's not a perfect square, so it cannot reduce. 20 is not a perfect square, but it does have a perfect square in it. If I go to my perfect square list, 4 divides into 20. So I can rewrite this as 4 times 5. So now we have, in the numerator, square root of 3, but in the denominator we have square root of 4, which we know is 2, so the 2 comes out, and then we have square root of 5. And we can't do anything with square root of 5. 5 is prime, and it's not a perfect square. So now this expression is square root of 3 over 2 square roots of 5. Again, this bar means division. We can't divide a 3 by a 5, so we can't do any division. Y'all are going to write that answer, and you're going to get marked wrong because mathematically it is incorrect. This fraction bar is division. The denominator is your divisor. If I walked in today and said, hey, 35 people, break up, divide into 2 square roots of 5 groups, you would look at me like I'm crazy because we only can do division when our divisor is a whole number. So if your denominator is not a whole number, this is unacceptable. So we have to write equivalent fraction. Well, from 3rd grade, we know to make equivalent fractions, we do multiplication. What we want to do is multiply by a term that's going to get rid of that square root of 5. It's going to make it a whole number. 2 square roots of 5 is a monomial. And the rule is to rationalize the denominator of a monomial, you just multiply by that root. Okay? So to rationalize, if I want to get this square root of 5 out of there to make it a whole number, then I have to multiply by itself, square root of 5. And if I do it to the denominator, I do it to the numerator. So everybody look, by doing this step, by multiplying both the numerator and denominator by square root of 5, you're doing what we call rationalizing the denominator. You're making an equivalent fraction. So now let's multiply. Square root of 3 times square root of 5 we know is square root of 15. 2 square roots of 5 times 1 square root of 5. 2 times 1 is 2. Square root of 5 times square root of 5 is square root of 25. Now you're going to say, but Miss Black, there's still a square root. But now look inside. That's a perfect square, which means I can simplify this. In my numerator, I still have square root of 15. In my denominator, I have a 2, but I now know the square root of 25 is 5. And that's connected by multiplication. So that makes my denominator 2 times 5, which is 10. And if I write in algebra square root of 15 over 10, that is an acceptable fraction because the denominator is a whole number. I could walk in class and say divide into 10 groups and you all understand. All right, let's try another one. I have 3x divided by square root of 2x. Again, be careful. This x is not in a radical. This x is. So you can't divide them. This one's outside the symbol. This one's inside the symbol. So we can't cancel those x's out. We can't leave our expression like this because, again, down in the denominator is not a whole number. If there's a root symbol in your denominator, it is not a whole. This is an unacceptable fraction, so we're going to rationalize, which means we're going to do multiplication. What can we multiply to a square root of 2x that's going to guarantee it becomes whole? Well, because the 2x is all inside the square root, we're going to multiply it by itself, which is square root of 2x. And if we do it to the denominator, we do it to the numerator. So 3x times square root of 2x. 3x is on the outside, it stays on the outside. The 2x is on the inside, it stays on the inside. So that's how you write it. 3x square root 2x. In the denominator, square root of 2x times square root of 2x. They're both the radicands. So we can multiply them together and we get 4x squared. So the square root of 2x times the square root of 2x is the square root of 4x squared. Well, we know 4 is a perfect square. We know x squared is a perfect square. So we can simplify this. So our numerator stays 3x square root of 2x. But our denominator, the square root of 4 is 2. The square root of x squared is x. Now everybody look closely. Is that my fraction? No, it's not reduced. See how this x is on the outside and this x is on the outside? We can divide them then. We know x divided by x cancels out. So this final expression is 3 square roots of 2x divided by 2. And that is how you rationalize the denominator with a monomial. Let's talk about more of this in our next module.